Unit 7, Part 4 notes, I can use vertex form to identify special characteristics and graph quadratic functions. First off, vertex form of parabolas. So this is different from our standard form. So if you stretch your brain back all the way to linear functions, if you remember linear functions had different ways of being represented, so do quadratic functions. So this is just another representation, another form that you can write a quadratic equation in. Now, this form is particularly helpful when you need the vertex because it is a vertex form. So it does give you vertex information, which you should have discovered in the activity in the Explore. But here we have y equals a times the quantity x minus h squared plus k. Your vertex is the h value and the k value. Now, one thing to note is that this has to be a minus sign for you to take the h value as is. And when this is a plus sign, k is positive. If it's a minus k, it would become a negative k. So we're going to talk about this a little bit more because these positive and negatives can get us a little bit confused. So if we look here, we have identify the vertex from the following equations. So right here we have y equals 3 times x minus 7 squared plus 4. So if I write the vertex form right underneath there, x minus h squared plus k, you can see how everything lines up. The 3 is in the a spot. There's a minus sign, then there's a 7 in the h spot, there's a plus sign, there's a 4. When that happens, the vertex is just those numbers. Your h is going to be 7, your k is going to be 4, h, k. It all lines up really nicely, and that's your vertex. Your vertex is 7, 4. All right, so here on the one to the right, if we write this form right underneath it, x minus h squared plus k, we can see here that the k is lining up nicely. You have a plus 6, so plus k, your k is going to be 6. However, there's a plus sign in the middle instead of a minus sign. So when that happens, we just have to do the opposite of that value. So instead of a 5, it is going to become a negative 5. All right. Now, the reason for that is if I rewrite it as x minus negative 5, then it would have that minus. We take the negative 5, and what does a double negative become? That really is the same as x plus 5. So when there's a plus, it's really that minus a negative. So we need to take the negative value of the number instead of the positive number. Otherwise, it will not be the correct value. So here's another way to show you. In the graph, you can see I've written the equation. If we go to where the vertex is, you can see it's that negative 5. Okay? I could also rewrite the equation and make it that minus 5. If I change it to minus 5, then you can see how the vertex shifts over there. It becomes parallel images. But if I make it minus negative 5, it becomes that same function. So minus negative plus 5, it does still give us that vertex at that negative 5, 6. So when there's a plus sign in the middle, it does need to become the opposite in order to make it the vertex. So negative 5. All right. So then if you have a minus in the middle, so y equals a times x minus h squared plus k, we have that minus in the middle, so h is just 3. So remember, if it says minus, then the vertex is going to be positive, so it's kind of opposite. But then here, when we have plus k, we have minus 7. So minus 7 is really the same as plus negative 7. So we're going to keep that negative with the value and make it negative 7 for our vertex. So again, I can show you on the graph when we have x minus 3 in the middle and then minus 7 here at the end. the vertex ends up being that positive 3 and then the negative 7. So it does end up being the same as if we were to put plus that minus 7 there. So you can see that green equation and then the red equation exactly the same. So that's how that works. So then here we have y equals negative 2x plus 4. So again, since it's plus instead of the minus, we're going to make it the opposite of positive 4, which is negative 4. And then plus k, it's that minus 8, which is the same as plus negative 8. So we're going to just keep that negative with it. So the first step in being successful with vertex form is making sure that we can identify the h and the k correctly. So that's why we practice this right away. All right, so now we are going to use the vertex form to graph a quadratic function. So the first step is to identify that vertex. We have y equals negative or positive 3 times the quantity x minus 3 squared minus 4. So there's that minus in the middle, so the h is just that positive 3. And then plus k is really plus negative 4k, so we have that negative 4 for our k value. So that's our vertex. So now we can plot that point on our graph. We go 3, negative 4. And then remember that axis of symmetry goes through the vertex. So the axis of symmetry is going to go through that point. And that x value is going to be the same as it is in the vertex. So it's going to be x equals 3. The next question, concave up or down. That concave up or down comes from the a value. Is the a value positive or negative? The a value is 3, which is positive. So it's going to be concave up. It's going to be a opening up U. The next piece is to solve for our y-intercept. So it's going to be similar to how we solved for our vertex in the original standard form. But for the y-intercept, we are going to replace x with 0, and we are going to solve for y, because the y-intercept is always the value when x is 0, and then you solve for y. So we replace our x with 0, and then we can use our calculator to evaluate that. So we have 3 times 0 minus 3 squared minus 4. So in this case, our y-intercept is 23. So in this case, we do not have the space on our graph that we're given to plot the point, so we're not going to plot the point, and that's okay. Sometimes that happens, and it's totally fine. So because of that, we are going to then rely on our creation of our table in order to get the points on the graph. So we're going to do it just like we did for standard form. We're going to put our vertex in the middle, 3, negative 4. Put 2 smaller numbers above, 2 larger numbers below. And then we can use our calculator to evaluate those points. So if I replace x with 2, I get negative 1. And then reminder, symmetry does state that those values are still going to be the same. We still have that symmetry piece. And then if I replace my x value with 1, I get 8. So then if x is 1, y is 8, and also if x is 5, y is 8. So now we can plot those points to negative 1, 4, negative 1, and then 1, 8, and 5, 8. And that gives us our shape of our parabola. And again, if you are doing this on paper, you can just plot the points and create the parabola yourself. But if you're doing it digitally, you can use the points and pieces given for you. All right, one last example. We have our equation in vertex form. So again, we're going to start with identifying that vertex. Y equals a times x minus h squared plus k. So in this case, since there's a plus sign here instead of a minus sign, we're going to do the opposite of positive 4, which is negative 4. And then we have that plus k, which is plus 8, so it just stays positive 8. So we can plot our vertex at negative 4, 8. And then our axis of symmetry will go through that point. And the x value will be the x value from the vertex, which is negative 4. All right, the next question is concave up or concave down. Remember that relies on our a value. So our a value is negative 2. So since it's a negative value, it's going to be that concave down. So when we graph our function, it is going to be, the parabola is not going to be concave up, but it will be concave down. So I can flip that around so I know it's going to be down. The next piece is to solve for our y-intercept. We are going to replace our x value with 0 in our equation, and then solve for y. So again, we can use our calculator. We have negative 2 times 0 plus 4 squared plus 8, and that gives us negative 24. So our y-intercept is 0, negative 24. And again, we don't have space to graph it, so we just will not graph that y-intercept point. All right, so the last piece then is creating that table so that we can create our parabola shape. So vertex goes in the middle, negative 4, 8. And then we put smaller numbers above, larger numbers below, and then use our calculator to solve for those values. So I can put negative 5 here, and we get 6 for the value. So negative 5 will be 6, and 3 will also be 6. That's symmetry. And then we can replace x with negative 6, and we get 0. So negative 6 will be 0, and negative 2 will be 0. So then we can plot those points on our graph. Negative 6, 0, negative 5, 6, negative 3, 6, and negative 2, 0. So then it did end up being that these two values, negative 6, 0, negative 2, 0, ended up being our x-intercepts. So that did give us an extra piece of information there, as we got our x-intercepts out of these values as well. And sometimes that does happen, and sometimes it doesn't, and that's okay. So we can try to line up this parabola shape the best we can. Sometimes they don't like to line up super nicely, but just do the best that you can. And that is all of the notes for this lesson. For your classwork, you will have identifying the vertex, just like we did at the beginning of the notes, and then 4 problems where you will do the graphing piece, and then 2 questions where you're asked to write a quadratic function that fits those pieces of information. It does give you the vertex, so I would use the vertex form. I would use the y equals a times x minus h squared plus k. So try it. It's a challenge type problem because I haven't explicitly taught you how, but you do have all the information that you need in order to accurately answer that. So just do your best. And then once you are done, make sure you go to Schoology and complete your check-in so you can make sure you did the problems correctly. If you have any questions, please reach out. Otherwise, the time is yours to work.